Hello friends, welcome to the third class of implementation of threads. Today we have to do the next function of thread, that is thread underscore equal. So first of all, let's see what is thread underscore equal. Thread underscore equal is a type of a function which compares whether two threads are same or not, which means that the thread ID of one thread is equal to the thread ID of second thread. If both thread IDs are equal, then the function returns non-zero value, otherwise 0 if both the IDs are different. As we have seen in the case of process also, the ID of the processes are always different when they are running in the system. Like in a college or in a university, each student is recognized by their registration numbers, so no two students are going to have the same registration numbers. Similarly, whatever the processes or threads we are having in our system, both the threads or both the processes are never going to have their same IDs or same thread IDs. So this program we have to implement, we have to check whether our threads, whatever we are going to create, are going to have the same IDs or no. So if they are going to have the same ID, it means it is going to return some non-zero value, otherwise 0 if IDs are different, means that is the best case. So let's see now the code part. The editor we are using is gedit, the same which we were using from the previous class, and the name of the program is, so I have already written this code for you. So let's see the code part now. First of all, two header files has we have used over here. One is pthread.h and stdio.h. Why? So we have already discussed in the previous videos that because this pthread and pthread.h library has been used because these two functions of threads are used in the program, that is pthread underscore create and pthread underscore join, and st.h because of the printf statements. So first thread pointer function we are using over here for the first thread, and we are displaying one line over here, that is thread 1. So one another function of thread has been used in this line of code, that is thread underscore self. So this we have seen in the previous video also. So this particular function is going to fetch the ID of the thread. Like suppose if thread want to know about his ID, so with this particular function thread may able to know about his ID. So after that, thread is printing his name also. We can consider that thread is displaying his name also, that is thread 1. Similarly, the second pointer function is used for the thread 2, because when we are comparing something, it means that we require at least two threads. So for the comparison, we require this second thread also. So we will be using the second pointer function for the second thread. So similarly, printf thread 2, again the data type, this one is the data type, the large data type which we are using in C programming and all. So see, another function is also fetching his ID with the pthread underscore self. So similarly, thread 2 is also generating his name, that is thread 2. So with these two sections of the code, thread 1 is generating his process ID. Similarly, thread 2 is also generating his process thread ID. So two thread IDs are generated over here. So then the main part of the program starts from here. So the main process will work at this place. The very first one is we are declaring two threads of data type pthread underscore t, and the name we are taking over here is thread 1 t1 and thread 2 for t2. Then the creation of the threads with the function pthread underscore create. Four parameters are there. First of all is the address of the thread 1, that is t1. Second value we are taking as null, the default attributes. Third is the address of the function. See, the function we have used for the thread 1, this th1. And the last is the null value because we are not passing any arguments over here. So with this line of code, first thread will be created. Similarly, we we can create the second thread also. And after this, the mandatory step we are having is pthread underscore join, which means that thread cannot stand alone. We have to join this thread with the processes. So which thread we want to join? This T1 thread with the process. Similarly, we have to join this T2 thread with the process. So after joining these two threads, then the main part of the program comes where we are going to compare the IDs of both the threads. So how we are going to compare? See, I have written one line of code over here, that is threads are equal. So question mark I am displaying over here, that whether threads are equal or no. So if 0 for no and 1 for yes, means that if I'm going to get the value 0, it means thread IDs are not equal, which is the best case we are proving over here. And if IDs of both the threads are, I'm getting the value 1, which means that IDs will be same, which is the worst case. No two threads should have the same ID. So this situation we are not going to face. So after that, uh, this is a particular function we are using over here, that is pthread underscore equal. Pthread underscore equal is going to compare the IDs of both the threads. So which means which two threads? T1, this one, and T2, the second thread. And after that one, after comparing both the IDs, one common message we are generating over here, that is simply process or any welcome message, anything you want to display. So let's see the execution part now. So before we execute, first of all we have to compile this program now. We know GCC compiler we are using for the compilation process, and the name of the program is thread2.c. and after that the option you have to use is, that is -lp thread, because we have to link the thread with the process. So see, compilation is done successfully. Now we have to run this program. So with the default output file is generated, that is a.out. So see, thread 1 whose ID is, so see the large numeric value we are getting over here, and the thread 1 is generating his name also. Similarly, thread 2 is fetching his ID. His thread ID is this one, as well as he is displaying his ID. From here only we can see this thing, both the IDs are different, which means our function is working successfully. So at the end we are displaying the line that, see, threads are equal, the question mark was there, 0 for no and 1 for yes. See the output, the main part of this is 0. We are getting that both the IDs are not same. It means that 0 value we are getting over here, and at the end we are getting the common message of process. So I hope you got the working of the pthread underscore equal function. Thank you so much.